All right. Hello. Welcome, everyone, to the Blazor Community Stand-Up, where we talk about the latest updates to .NET web development. I'm Daniel Roth. I'm the Principal Product Manager for ASP.NET Core and Blazor on the .NET team. And I'm joined by Javier Calvarro Nelson, Principal Software Engineer on the Blazor team. Welcome, Javier.
Hello, everyone.
Of course, Javier, you have a role update that recently changed. I believe you are no longer just like our Blazor principal software engineer. You are now architect, correct? Like architect for
Sure.
ASP.NET Core?
Sure. I will always say that I'm just a developer, but yes.
That's awesome. Congratulations on your expanded role. Javier has been doing amazing things for Blazor and ASP.NET Core for many, many years, and he's now been asked to have an expanded influence across the team, adding Javier goodness wherever he goes. So that's great. Congratulations on that, Javier.
Thank you.
Cool. So today we are here to talk about a cool and interesting topic. We're going to be talking about end-to-end component testing for your Blazor components. And some recent updates, some new and experimental things that we're working on that you'll see some early bits start to flow with some of the .NET 11 releases. But we wanted to give you an early preview of those things that we're working on. By the way, that .NET 11 preview 4 release, the next release, should be coming out shortly, maybe within hours. We'll see. So keep mashing the refresh button on the .NET website, looking for that. There should be some new bits that hopefully will be landing today. But today we're going to be looking at end-to-end component testing. You may remember, like back in when we shipped .NET 10 back in November, we did some improvements around end-to-end testing for ASP.NET Core apps, not just Blazor apps, but really any web UI app that you were working on. This was with the web application factory abstractions that we ship inside the framework. Web application factory is sort of a way that you can historically, so that you could stand up like an in-memory instance of your ASP.NET Core app. You could substitute out services and then get a HP client instance that was wired up to then talk to that app. So you could do testing patterns with your application. And that kind of sort of worked for web UI apps. Like you could, if you were willing to like parse the HTML and do validations on the responses that came back from your server, you could kind of make that work. Of course, a lot of people prefer to do, when they really want to do an end-to-end test, you want to use something like Playwright or Selenium, like some sort of browser-based solution where you really need the whole browser platform. So in 10, we did some work to make it so that you could use Web Application Factory and actually stand up an actual endpoint, like have Kestrel stand up the application, so you could point Playwright or Selenium at your application and do an end-to-end test. So that helped some with your end-to-end testing scenarios. But I guess there's still more to be done, Javier. Is that right? There's still some problem spaces and issues there that we want to improve.
Yeah, absolutely. So I would think that what we did for Web Application Factory was more of a stopgap solution than an actual solution to the problem itself. If I go down from memory, if I walk down memory lane, Web Application Factory happened like 10 years ago because we were building MVC and we needed a way of testing it, and we realized pretty quickly that the things that we were building ourselves were very useful also for customers in order to be able to test their applications. And that's essentially how Web Application Factory came to life, and how we decided the set of features that it should have, because we ourselves in the framework were using it to test. Now,
I believe you may have had a direct hand in the creation
yes,
of the Web Application.
it was one of my babies at the time. Although I long lost let it go to work on other things, but and other people have continued making it better. But yeah, when we envision a Web Application Factory, our goal was to do in-memory integration testing of MVC and Web APIs. We never thought of doing actual end-to-end testing with it. And one of the reasons for it is that while you can use something like Web Application Factory and make it as through extensibility, make it like launch a Kestrel instance, you're going to have to solve a set of problems that you didn't have before. Like, for example, you're going to have to either run your test sequentially, or you're going to have to spin up uh, and deal with the port selection, so that you don't spin up multiple servers and have them conflict.
Yeah, I know. I love that one of the ways that we arrive at our testing solutions that we provide as part of ASP.NET Core for Blazor developers is often through our own needs. Like we're writing integration tests for like our sample applications that are written in Blazor or MVC or Razor Pages or minimal APIs, SignalR, or whatever. And so we build up test infrastructure in order to facilitate that testing of the framework itself. And as we do that, we learn patterns and things that we feel like can be made more broadly available, more useful for everyone. And then if they graduate, they can ship as part of the framework and become available to you all. So that's cool. And then obviously we want our CI tests to be as stable as possible. Things like where, every now and then you accidentally get two apps that have the same port get wired up and they collide. Like that's no good. No one likes when the CI fails just, once every week or whatever because of a random failure.
Exactly. So one of the things from this journey is that in Blazor ourselves, we have some end-to-end testing infrastructure that we have grown organically over the years, to put it in a kind way, and it's not the best. So we are trying to amend our past scenes and produce a better integration story for us moving forward. And one of the things that agentic development allows us is we are able to much quickly do bigger changes like updating tests and things like that. That once we have set up a pattern, the AI can just go and like do the update. In the past, this would have cost like a month or 2 months of a developer going through and making all the tests upgraded. Now it's definitely something much more achievable. So one of the things that we've learned over the years of writing end-to-end tests for Blazor is we have a very good grasp of the patterns that make a test reliable and the patterns that make a test flaky. We have developed custom solutions for specific problems that allows us to make tests reliable. For example, whenever you are testing things like pre-rendering, you want to be able to reliably stop the app or be able to look at the app before the app becomes interactive. You want to be able to do things like, I'm going to hold on making the app interactive up until I asserted everything. Then I'm going to make the app interactive, and I'm going to assert on the interactive versions of the app. Or
an evolution, yeah.
Exactly. If you're doing streaming rendering, how do you test a streaming rendering? Because streaming rendering is like, I'm going to show you something, and then I'm going to replace it as it goes. Those things are very timing based, and we have mechanisms in place and solutions that we have developed locally that we have created to make those things reliable. So one of the things that we are trying to do with this new library that we are building is providing those sets of things as built-in infrastructure that any app can use to make their tests reliable by default. There are other things that are important here. So one of the things that is very interesting is in this world where like a good proportion of people is using AIs to write tests and to do things. One of the key things that everybody that uses AIs to write code knows is that observability and instrumentation is key. So as I mentioned, we are working on a set of skills for improving the way AIs write Blazor applications, which we'll show at another time. But one of the things that we want to focus on is on the end-to-end loop that the AI uses to write new features, and making sure that we provide all the information and all the instrumentation that it needs to be able to quickly spot and correct problems. And one of the good things about this is that all these investments in infrastructure, in instrumentation and observability and things like that are things that not only the AI benefits from, but also any regular user that is not using AI, that doesn't want to use AI for whatever reason, they can still benefit from the additional observability.
So it's not just that you want to be able to write end-to-end tests for your Blazor app. Also, when those tests say like they fail, you want to have enough diagnostics, information available, observability available, so that an AI agent or human could go in and actually understand like what happened here, like why did this fail, what went wrong, so that the agent can then address those issues.
Exactly. So things like traces, videos, things like that, we want to make we want to capture those by default. We want to be able to retry the test when it fails automatically, so that we can capture additional data that then either a human or an AI can look through and identify the problem and work on correcting. So there's another thing that is interesting, which is, I would say the top feature of Web Application Factory was the ability for you to override services, was the ability for you to change the services that were registered on your test, so that you could like do specific tests and so on. And when we look at, so that's the good thing about Web Application Factory. But then when we look at using it end-to-end, it had a bunch of shortcomings. We talk about the port selection. Even if you are able to avoid any port conflict, normally when you are doing end-to-end testing, you want a stable URL, because maybe you have some security thing that you're doing with OAuth or something like that, that you want to exercise in your test that needs a stable URL, or you need other things like, oh, sorry, my mind went blank for a second. You might need to have, there are many reasons why you might need to have like a well-known URL, that you cannot just pick a random URL. You might need to, when you are doing end-to-end tests, not run your test really against your like build app, but you might want to run it against your publish app, because ultimately that's the thing that you're going to deploy, and you want to be as close to production as possible.
Yeah, particularly with like I assume with like Blazor WebAssembly apps, that would be particularly important because of like all the processing that happens as part of the publish step.
Exactly, because of the trimming and so on. So those three type of things are the things that we are trying to solve with this library. So this library is from the beginning conceived as the way of testing your app end-to-end. And the main difference is that it is, how do I say it? It is defined in a way that it is conceived as a way of you starting your app for real and then pointing the browser to it, and us managing all the infrastructure for that to be reliable.
Sounds cool.
So I think we can go ahead and see some of these things in action.
All right, here,
I don't know if there are any questions on the chat that we want to address.
Not related to this yet. There were some people asking some general questions, like someone had asked about some should they build with minimal APIs or API controllers. Definitely would recommend minimal APIs if you're starting with something fresh. And I think folks from the community also commented as such. That's definitely consistent with our guidance, but not related to the testing stuff. So I think you can go ahead. Do you want me to go ahead and show your screen?
Yeah.
All right, here we go.
Awesome. So I am showing you the README from the older prototype. This is already changed name and it's on the repo and so on. But in a short description, Microsoft aspnetcore components testing is the web application factory of end-to-end testing. It has a very similar model where you point your test app to your test library to the apps that you want to include, and we will grab those apps. We will capture where they live on your local machine and everything, and you'll have a way of spinning up a new server and getting a Playwright instance that you can use to talk to that server. And we will launch your app as a new process, same as you would do in an end-to-end test. You can choose to do that with the app without publish, so you can let the equivalent of .NET Run. We actually literally just do .NET Run on your app in a separate process that we keep track of. And you can also choose to tell publish the app, and at that point we will before running the test during build time, we will publish your app, we will copy the output, and we will run that app as a published app, as a separate process again, and give you a Playwright browser that you can use to talk to it. So the interesting thing is that we wanted to keep the core feature of Web Application Factory working, which is the ability to override services. And we did a thing to make this work in end-to-end testing, which is, I think, very interesting. So in general, this is more or less how our testing infrastructure works. Our test process is right now using XUnity 3 and Playwright. And we talk about the port selection problem. Okay, when I spin a server, I have multiple. If I try to spin multiple servers, then the ports will conflict, and I either need to choose a random port or do something else. So one of the things that we do in this library is we automatically start your app in a random port. But in our test process, we actually have an instance of YARP running locally, and we map your app and that instance that we just launched to a specific instance. So we configure Playwright to automatically send a header on all the requests that come to that public YARP proxy instance, and we use that header to route the request to the actual individual instance that we just launched. So we give you a public URL that your test target, even though the individual instances are running on an individual port. So we avoid any sort of port conflict. The other thing that we do for you is we make sure that the app is up and running before you start a test. So you don't have to be waiting specifically to like, hey, I tried to load the home page, and if your test application fails to run for some reason, we will detect that. We will detect that the app didn't even like started. So one of the things that we do is we grab the test project itself and we inject it into all the processes that we launch through a startup hook, which is a mechanism that exists in .NET to load a DLL into a process during startup and do things. And we configure a bunch of helpers and infrastructure there that you can use within your test to transparently how do I say it? To transparently make the test more reliable. So, for example, let me see if I can go here. Unfortunately, the diagram is cut here, and I cannot see a way of like showing it. But let me kind of walk you a bit through what happens in a test. Let me show you. Okay, so our basic test is we have this server instance, and then we initialize our fixture. We have this is using XUnit, so we have everything set up here. In our homepage, we essentially have the fixture for our test assembly, and we create a new context, and we configure the options. And you see this like with server routing. This is the helper that we provide to tell Playwright for every like modify every request so that it contains our special header, so that we can route to the instance that we just launched. This allows us to run multiple servers in parallel if we need to.
Is the library dependent on Playwright? Like, is it only work with Playwright, or does it work with other frameworks as well?
Right now, it only works with Playwright, and I might be able to extract it into more pieces so that there is kind of a core library. Right now, it's all tied to Playwright and XUnit, but it might be the case that, and this is one of the reasons why we are not making it RTM, is because we want to figure out which are the different flavors that we need to consider supporting. At some point, I think it might be useful for us to let you use whatever testing framework you want, provided that it has the features that we need to make this experience good. But there is a limit to how useful it is for us to support Playwright and Selenium, for example. One of the things that we want to do, especially if we are pairing this with a skill to help agents write tests, is pick up a winner, sort of speak, and say, well, this is the thing that best fits our needs, and this is the recommended way that we're gonna do things moving forward.
Okay, so that's important. That this library, we expect to preview it in the 11 timeframe, but we expect it to stay in preview, to stay experimental for a little while longer while we sort through some of those big questions. So if this is
exactly.
if folks feel like XUnit and Playwright is all you need, then let us know. Or if you feel like there's other frameworks you really need to integrate with, that will be feedback that we'll be looking to hear about. And this project is happening in the aspnetcore repo, so that would be where they would file issues, right? If they had like requests for the component testing library.
Exactly, and I want to be very clear that our goal here is threefold. One is we want to improve our own testing, our end-to-end testing infrastructure, and modernizing, because it's going to save us on support and other things like that. Second is we want to make agents be able to write better Blazor apps and be able to like test Blazor apps and have a smoother development cycle where you have an easier time just checking the results and making sure that everything is okay, but the agent is more able to autonomously iterate on features and fix issues. And third, we want people to be able to also do the same things that they currently do with Web Application Factory and that we do in our end-to-end testing with their own things. For testing things, we feel that is not that problematic, that, hey, this is a preview and things will change for sure, and we'll have to react to feedback and things like that, but you're not blocked from using it. If you don't want to use it, you can use base Playwright. You can copy all the code from the library into your own test project and make it your own. There are options. We're trying to give you a way of doing this or streamlining this experience, even being very clear that some details will change as we work on making these things RTM. I think it's useful for us to just deliver it to you even in preview form in 11 so that you can start using it rather than us waiting another year to make it available.
Regarding
the
making it available in preview in 11, so I think the NuGet package will actually show up in 11 preview 4, although I think it has some rough edges on it that's not quite ready for full consumption in preview 4. But the next month, like in the preview 5 release, I think is when we expect that will be the first time when they can really start giving it a try. You could probably use it in preview 4, but you might need like a workaround or two to get things to really work properly. So just give you a feel, folks, for when you actually be able to get your hands on what you're about to see in Javier's demo. Like it's coming soon in the .NET 11 release train, at least in preview form.
Yes. Let me see. This is more or less how you set up the test, and essentially it's more the initial setup than anything else. After the initial setup, you're basically using Playwright. So this side page is Playwright. And the setup is very simple. It's like, here's the fixture, please start the server. If we are not able to start the server for some reason, we will get an exception here. And the things that we're trying to kind of make it good are things like some developer makes a mistake and it causes the app to not even start. In our CI, we had that problem for many times, where if a developer is doing a change, all the tests will fail to even start, and the run will time out. So we want to be able to do things like we want to very clearly identify those cases where there are barreling failures or failures on a very fundamental level, and just try to skip the run as soon as possible. So this is all an experience that is a work in progress still, but trying to solve in general the pain points that we ourselves see in our more than 1,000 to 2,000 end-to-end tests that we currently have.
That app generic parameter, is that the app component in the Blazor app, or is that something else?
Yeah.
So does that, usually that's there's code in your startup logic that says map to map Blazor component or whatever, where you specify the sort of root component of your app in your your program CS file. Does this run the full program CS logic as part of starting up the app, or is this kind of?
So we only use the app here to find the assembly, to find the app. So I have not shown that. But in here there is a package reference here. A project reference here, and we have this end-to-end app metadata on the project reference. We use that to, at build time, create a manifest of all the apps, and the manifest contains the target name for this reference, so the Blazor web app. What we do with this app that you see here is we get its assembly, because this is a type, and we use that assembly to match it to the name that we put in the manifest. And that's how we correlate, because you can imagine that on a testing project, you could be testing multiple websites, and we need to have a way of distinguishing which one do you want to start.
Makes sense.
So the moment that happens, we literally are going to call by default .NET Run on this Blazor web app. So that's gonna run your program.cs, is gonna run in development, it's gonna do all the things. And this is one of the things that I was mentioning, that maybe that's not exactly what you want. You want to be able to test the publish app. There is a setting here that you can say, I don't remember which, but I think it's published or something like that. So if you do publish true, we, instead of just running .NET Run, we will publish the app into our bin folder, and we will do .NET Run on the actual Blazor web app DLL. And that will run the app in production and everything. So you get the real testing. So if you have, for example, a Blazor app, and that Blazor app has a WebAssembly on it, we will trim, we will do everything. And if there is a problem with trimming and things like that, you will be able to see it in the test.
Someone asked about like, is it using Playwright in like a headless mode, or is snapshot testing also possible with this setup?
Yeah, so right now it's using Playwright testing in headless mode. We are not doing snapshot testing, but that might be something that we add. We want to work on this ourselves to identify the list of features and things that we feel that are useful. Part of that is also improving our own testing infrastructure, to be very honest. But the one thing that we do is, going back to the observability thing that we were talking about, is we make an effort to capture all the artifacts by default. So if you are familiar with Playwright, you normally need to ask it to like capture a trace or record a video, things like that. All those are things that we're trying to build into the library directly, so that one, you as a human don't have to be doing this thing manually and think about them. And also that when you are using AI agents, these things happen automatically, and you don't have to take an extra step, or the agent doesn't have to take an extra step to then go and capture the things that it needs to in order to be able to trace things. So I wanted to show here an example of what I was talking about, which is we automatically set up the trace to be captured. So this was me running the counter component, and you can see here that it's running against the actual port. From I can go into launch settings.json in a second and show you. I can show you that it's waiting here and clicking, and then it's validating that that the count gets incremented. So one of the things is that if I go here, so the library automatically configures all the paths for everything. So it shows here the traces that by default they get captured in the bin folder. So this trace, I literally just went through to trace.playwright.dev. I uploaded it there, and it showed me all these things that you're seeing. Which is very useful for a human to understand what's happening, and even for an LLM to just be able to crack open this trace and just go to identify the details, or use some NCP server that knows how to parse the trace, and so on and so forth. And all these things happen by default. All these things are configurable. So if you are on CI, you can change that environment variable, and then automatically all these traces get put into the right folder that then gets exported to artifacts, making it much easier for you to see what happened when a test failed, essentially. Which is the other thing that plagues us. When we have a failing test on CI, we don't have a good way of seeing, okay, this test failed. Where did it fail? What happened? And so on.
So all that data gets collected along the way, sort of as part of the setup of this particular testing framework.
Exactly. So the other things that we were mentioning are things like, how do we make some of the tests reliable? And here are the type of things that we are doing, and this library provides. So it is very typical that you want to assert the outcome of pre-rendering before getting the app to be interactive. And we in Blazor have tricks for this. We changed the program.c. We changed the app.razor on our test to not automatically start Blazor. We set up cookies. We refresh the page. We do a bunch of tricks to make this happen. Not all of them are great tricks, to be very clear, are things born out of necessity. And I imagine a lot of people also do this type of thing. So one of the things that we want to change is we want to provide primitives to do some of these things. So Playwright, for example, allows us to Playwright, for example, allows us to intercept network requests. So if we want to test the outcome of pre-rendering, we can just tell it we're gonna capture any request to Blazor Web.js, and we're gonna hold the page indefinitely so that we can do all the assertions. And once we are done doing the assertions, we're just gonna release the log, let the request go through, and then we can do additional assertions on it. So this is more or less what is happening here. We are telling it hold on to loading Blazor Web.js, and then go to the weather page. Wait up until it has initiated the request, and then once it has initiated the request, do this couple of checks, and then let it continue. So that's, for example, a way in which we test pre-rendering. There are other ones. Let me see. Yeah, so there are things like, I want to be able to wait for enhanced navigation. You normally need to like register an event yourself in the test and so on. We want to make all those things first-class concepts so that you can reliably depend on those things instead of creating your own, which is going to result in flakiness. One of the interesting things, I don't know if I have it here. Let me see.
These are all these like, somewhat fairly Blazor specific concepts, like optimizations that Blazor does, like to enable streaming rendering, enhanced nav, pre-rendering, and then switching to interactivity. That if you really want to check like every stage of your app that it's doing those things correctly, that the behavior of enhanced nav is actually correct, this sort of lets you get visibility into the life cycle of the page as it's going through those different phases, and to check along the way, like, okay, did the enhanced nav actually work correctly? Yes. Okay, good. Then we can move on to the next step of the app's life cycle.
Exactly. So I don't have it in that example, but I have it on the set of tests that we wrote so far for this new feature. As I said, one of the like key things of like Web Application Factory was the ability to override services. So
I think people were clamoring for that. They want to see the dependency injection in action on this, Javier.
Exactly. So this happens through a lot of like magic, but essentially the way we make this work is, I said that we are injecting the process, and we have these configure services here with these test overrides. So if we look at these test overrides, these test overrides has like this fake weather and this lockable fake weather. So this lockable fake weather, you see that they are being registered as like singleton and scoped. Let me go back for a second here. Let me see. In this case, we are essentially using this this callback to say, I want you to call the lockable weather method on this test overrides class. What happens is that as part of the library, we have it here. We have a source generator that we created, and essentially the source generator will identify those service override call sites, and we will it will create a map essentially, so that when we inject or test DLL, we will pass an environment variable saying, this is the override that you need to run for the test that we are about to run. That means that you can have like multiple classes and do this multiple times. Every time that you essentially call start server, you can do this, point it to a different method, And the main thing that this method needs to have is that it needs to be like a static method. You cannot pass any kind of per test parameter here and so on. We could make that even better if we wanted to, like being able to serialize some parameters and things like that. But essentially what's going to happen is that our test DLL is going to be injected in your running process. It's going to run the configure services. It's going to invoke this method with the service collection. It will allow you to override any service right at that point. And from there on, you can have this lockable weather service. It's also an interesting thing because it's implementing the iWeather service interface, and it has this test log provider. And this test log provider is also a utility that that we create. We were talking about doing things like testing weather forecast and being able to test the loading state. And that's very time dependent. So in order to avoid flakiness or flakiness in many of our tests, what we normally do in these situations is we use a task completion source. So our test log provider is essentially a built-in utility of the library that when we inject our test DLL, it contains all this logic. It registers all these like test services that then you can use in your test implementations or in your test mocks to say, hey, if there is no session, I want to wait on this log. We provide an endpoint that we can from the test project, which let me just go back to it.
Just what that session was. Is that is that some identifier that's getting created for a particular user session? What was that?
Yeah, it's an identifier. It's an identifier that is getting created for the actual test instance that that we are initiating.
Okay.
So we essentially have this list of logs. Let me see here. So we have this test log client. We say, hey, go and create me one for this server. And here's my playwright context. We essentially say, please log on this weather data. So we send an initial request to say, hey, go and create this log. Then we go and navigate to the page. And then we expect the page to be visible. We expect the loading state to be there. And later on, we release the log. Let me see where we release. Well, we release the log here. And then we await up until the navigation finishes, and then we check that the table is there.
Gotcha. So, okay, so there's really two things that you're showing here. One was the like, if I want to mock out or add custom services, you can create a static method that will get access to the service collection and add and modify services on that service collection, correct? And then the services that you add, there's also additional services that the framework will add, like these locking services that will help you then write tests and coordinate things so you can see every sort of stage of the user interface as it's being rendered and making sure that it's behaving correctly.
Exactly, so that you can deterministically control how the UI progresses through the test. And it's kind of like having I don't want to say it this way, but a distributed task completion source. It's a big dictionary where we have the task completion source and a list of like keys. And then you're able to create a key, and then you're able to dispatch something to say, go and release the key so that the test can continue. Okay. And we do that through these logs.
Someone was asking for details about how the services or more details about how the services are actually getting injected. So they like when Fred asked, is it intersecting get service and get required service rather than somehow
awesome.
Is that how it's working through that? You mentioned there's a source generator involved.
Yeah, can you hide my screen for a second?
Yeah.
Awesome. So the way this works is in the same way that it works for Web Application Factory. Web Application Factory has a couple of ways of intercepting and overriding services. First, it did it through a startup filter, which would wrap the configure services method. And then in the new program.cs, there is a diagnostic event source event that gets triggered. And we listen to that diagnostic event source event, and we call or callback on the service collection. And we use that callback to override services in the collection. So the way we get there is through a startup hook that we set up to load our test assembly when the dotnet process starts. That startup hook sets up a hosting startup assembly environment variable, so that then aspnet, when it runs, loads our additional services. And within that hosting startup, we do the setup to call the configure method, which we have injected as an environment variable. So our source generator, all the thing that it does is it says, it locates all the places where you call configure test services or whatever the method is called, and it takes note. It says like, okay, this class and this method, I'm just gonna put it in my manifest, and it builds a dictionary of those methods and those keys and just calls them during startup at the right time.
Wow. Okay. Wow. So pretty clever stuff. Sounds cool. Okay. Some people were asking about the YARP setup that you mentioned. That you do when the app runs, it runs on a random port, but then you have YARP running in front as a proxy to provide stable URLs. I think you even said that they were public URLs, but I assume you don't mean like they're actually like public on the internet.
Yeah, not public in the sense of not public in the sense of like exposed outside of your machine. Public in the sense of the URL that appears in your launch settings.json.
Gotcha. Okay, and that's the URL that that Playwright would actually be interacting with, as opposed to the
exactly. Yeah. Exactly. When we set up Playwright, it's all configured through that, but we set up some header routing, which is what the YARP instance that we run locally is for, because our instance of YARP essentially listens on all the public, on all the launch settings URLs across all your projects that you have referenced across all the launch settings URLs of all the apps that you have referenced in that specific test. All your tests always point to YARP, and there is a header that we use on a per instant basis whenever we do that server.start async to route that specific Playwright instance to that specific instance that we started of that specific server. Gotcha. That is the bit of the initial setup that we do there. So this means that if your app is using OAuth or is using any sort of like callback or redirect or anything like that, it just works. You're not gonna find yourself that, oh, I need to go and change something in my configuration on an external service because I messed something up. And you don't have to be worried about the ports conflicting or the tests trying to run on a conflicting port, because they're going to pick a free port by run. They're going to pick a free port automatically at random. So they are essentially going to ask the operating system for a free port.
Someone asked about the Blazor gateway and whether or not this was this helps in this situation. I assume they were just making the connection that both the Blazor gateway and this testing framework are using YARP as a proxying system to talk, like, for example, if you want to talk to backend APIs in the case of the Blazor gateway, like when you're running in a distributed app environment. But they're not, I assume we're not like using one as part of the other, or is there any?
No, I mean, you can obviously see the inspiration of me building the gateway and then me building this thing. The main thing that they both have in common is that they use YARP. but the gateway really doesn't really help here. The one that is doing the magic is Sharp.
So the gateway will help in the future, like, and we haven't actually released the gateway yet, but when it is released, it will help with your local development experience. Like, we expect it to replace the Blazor dev server that we have today and be a more feature rich dev server, including providing like proxying capabilities. So if you want to be able to talk to a backend API and have that look like it's all in the same origin, you can configure the Blazor gateway to do that during local development. It will also help with Aspire distributed scenarios where we're coordinating things like the service discovery down to the client, handling OpenTelemetry flowing from the client back to the OpenTelemetry stores and those types of things. So that's what the Blazor gateway is really targeted at.
Yeah, there were already very few things that were development specific on the dev server itself. I kind of worked hard to remove as many of those as possible. And the gateway is mainly just a simplified dev server that has additional features to make it support more production-ready scenarios. And as you said, if you're using the gateway and you're using it in development, it has YARP in it. You can go and configure the YARP configuration in the same way that you would do in Aspire. It can help in local development scenarios, like if you are doing integrations with other single-page application frameworks like React, things like that, you can configure the gateway to proxy the React and Angular resources for the dev server, so you can make it so as if everything is served from the same origin, and that will definitely help. If you have APIs that you are running, you can also do that sort of thing. If you are doing any type of distributed application development, I would highly encourage you to use Aspire instead. That's kind of my take. But for there is a small slice of the world between using Aspire and I have to do this small extra thing that the proxy might help you.
Speaking of Aspire, like someone asked about the relationship between this end-to-end testing solution and working with Aspire. Like, and I'm actually not super as familiar with Aspire's testing story. Like, but is there an integration point between using components.testing with an Aspire application that people should note?
So this is also another reason why we'll probably hold on into making it RTM, because we probably need to figure out a story there. There are definitely overlaps in our story. What I would say is that you shouldn't need to like set up Aspire to do end-to-end testing. If you're using Aspire and it already works with you, then use that by all means. I think Aspire is one of the legs of the story, but in the sense that it helps with like process management and spinning up services, dependencies, and things like that. But Aspire will not do things like what we just saw, that I want to start this app, but I want to override the services. Yeah, like Aspire will help you in like truly end-to-end. I need to test against my local Reddit instance and things like that.
Well, I kind of wonder if what they're really asking here is like the end-to-end test for my app. If I am using Aspire to build this app, then it's not just a single like Blazor project, right? It's a Blazor project that's sitting in a solution with a bunch of backend services that are all being orchestrated by Aspire, and I need to actually get that whole system up and running in order to do the actual end-to-end test of the application. Like, instead of just a .NET run, do I need to do an Aspire run on this application as part of that test? Thoughts on that? Is that how you would imagine doing this, or would you actually recommend like you actually should start mocking out those other processes if you really have multiple processes involved, instead of trying to really test that entire system end to end?
It depends on how real you want to get to with your end-to-end testing. Yeah. Like, the bigger the system it is, the more that you can say, hey, I'm gonna do testing production and things like that, where you set up an entire test environment to do this type of thing. For many teams, the way they operate is they spin up their UI and they mock the backend services so that they are able to test the entire UI.
Yeah.
Like there is a cost of trying to test the entire system, and the bigger it is, the bigger the cost.
So this is
So I would say
about than like end-to-end system testing. This is more about end-to-end testing of the front end of the UI piece.
exactly that's a very good way to put it. And the other thing is that in the future, some of these things might be complementary. We might find a way in which some of the things that we're doing here accrue to testing Blazor end-to-end apps in Aspire. I can already see that all the things that we are doing specifically for test logs, things like that, are useful independent of whether you are doing Aspire or not. Aspire is mostly helping in orchestrating all the dependencies set up and like spinning up all the services needed to actually run the app. That's the real value. Yep. And we have a very simplified version of that, which is we're literally just gonna .NET Run or .NET Publish your process and allow you to override services.
Cool. I know we're getting close to time. I'm sorry if we didn't get to everyone's question here. If we didn't, you can still reach out to us. Like you can find us on GitHub. You can of course find us on social media in various ways to get your questions answered there. Javier, for people that are interested in engaging on this project, I assume they should just go to the aspnetcore repo and that's where they should either open discussions or open issues related to this topic.
Yeah.
You can definitely already see there was a pull request that's already been merged, which I've added to the resource links for the stand up today that you can go check out if you want to see the work that's already been done. And like we said, in upcoming previews of .NET 11, we expect to have a version of this library for you to try out. They're not quite available yet for you to ready yet for you to try, but they should be available soon, and we'll be providing content on how to do that as the bits become available.
Yeah, cool. And this one is one of those that is definitely a work in progress, and it will evolve.
That's what we have these stand-ups for. Like the goal here is to be able to share the early thinking and work of the team. And, as we're working on previews for .NET 11, new features that we're working on in the repo, we want to engage with you folks in our .NET community and ecosystem to get your thoughts on the direction that we're going and enable you to participate with us. So yeah, awesome early read on this end-to-end testing work. All right.
Awesome.
Thank you, everyone. I think that's it for today. We will see you next time. Happy coding, and until next week. Cheers.
Thank you, everyone. Bye-bye.